So now we're going to try and make our programs a little bit smarter, and we will do this by making our programs only run certain pieces of code depending on certain conditions being met. Java uses if statements to do this. In this example, we're going to print a message when the value of num1 is less than 10. We set the value of num1 to 5, so it is going to run in this example. But if it was set to 15, Java would just skip over the code inside of the curly braces, because the code is only executed if the condition is met, so we wouldn't get the message. But what if we did want a message when the condition wasn't met? Well, we can add an else to our if statement. The code within the else case is run whenever the condition for the if statement is not met. So if we set the value of num1 to 15 now, we would get a message. Okay, but what if we wanted even more control? Well, instead of just one if statement, what if we had 2 or possibly more conditions that we know about? Well, Java also has an else if condition. This goes after the first if and before the else, and you can have as many of these as you want. In this example, you would get the message saying that num1 is not 10 or 12, because num1 is 5, and so it doesn't pass the conditions of the first or second checks. An important point to make here is that the order of the else if statement does matter. Java will cycle through all of the different cases in the order that you write them. If you're looking for more complicated conditions than just if a number is equal to another number, you will need to start to consider the order of the checks. When Java is running through the code, it checks from top to bottom, and so you'll want the most unlikely events toward the top of the list. This gives them the most chance of being executed. If you were to swap the conditions on lines 11 and 13 around in this example, the code on line 14 would never be executed, because once Java finds a condition which works, it stops looking through the rest of the if statement. It's important to know when to use more if statements and when to use more else if statements as well. Each if statement is like a junction in a road. It gives you multiple directions that you can travel depending on where you would want to go, while each if, else if, or else is one of those exits. Adding more else ifs to a statement increases the number of exits at that junction, while adding more if statements to a method is like adding more junctions to a road. Just like the way each road junction can lead to other junctions, and those junctions can have exits. You can put if statements inside else if statements, and else if statements inside those. There are no limits around how many if statements can be inside others, but your code can get very confusing very quickly if you take this idea too far. It's much better to have roughly 1 or 2 levels of if statements per method, and to make use of methods to keep your code readable. Just a side note here too, you can really start to see the benefit of white space here, particularly on the indentation. It allows you to see clearly which code belongs to which condition at a glance. There's no questioning involved at all. As we have been talking about if statements, you may have noticed some symbols within the conditions. For example, I said that num1 is less than 10, or num1 is equal to 10. So we should probably run through what options are available when it comes to comparisons. We have less than, greater than, less than or equals to, greater than or equals to, equals to, not equals to, and finally not. One quirk of Java is that it treats strings differently when it comes to comparisons. If you want to compare a string, you need to use the equals method, which is automatically assigned to each string that you create. So you would compare 2 strings with string1 dot equals and then string2 in brackets. There is also a case insensitive method too, which is equals case insensitive. Because there are so many operators, it's possible to write the same check multiple ways, and there's not really a right or wrong way to do something. What matters is that the code will make sense to you if you don't touch the code for maybe a year. You may have also noticed that we joined multiple conditions together. We're only going to use 2 of the combination types in this series, but there are others. The first type of combination is AND, which is two ampersands. If you use AND between two conditions, you're telling Java that both conditions must be true in order to run code. The second type of combination is OR, which is two pipelines. With OR, you are telling Java that one side or the other side or both sides must be true in order for the condition to pass, and therefore allow the code to run. And you should also know that AND takes precedence over OR when Java is evaluating the conditions. You can also use brackets to group comparisons together. In this example, I've grouped conditions 2 and 3 together. Brackets take priority over both AND and OR, so either condition 2 or condition 3 is true, and condition 1 is true, then the check will pass. It doesn't matter that condition 3 is false, because we have used OR and condition 2 is true, so the OR will pass. I would recommend using brackets every time that you use both AND and OR in the same condition, rather than writing the code in the perfect order, because it saves you trying to figure out exactly what's happening later on. It makes your code much more readable. There are also some alternative layouts for conditional statements which I also want to run through. The first alternative requires that you only have one line of code which is conditional. If so, you can skip putting curly braces and either have the code that you want to execute on the next line, like on lines 10 and 11, or follow on from the condition on the same line, like on line 13. Line 15 shows what's called an inline ternary. In this example, we're just switching which words we assign to the text variable. These are normally used when assigning values, but they work in other places too. They are essentially an if-else statement on one line. You put a condition in brackets like you would normally in an if statement, and then you use a question mark immediately after that closing bracket. You then do whatever you want to do for the true condition, followed by a colon, and whatever you want to do for a false condition. One thing to be aware of here is that you must have both pass and fail conditions for an inline ternary to work. You'll get an error message if you skip one or the other side. One final alternative to more traditional if statements is switch statements. Switch statements are a great way to replicate what would otherwise be else-if statements, where there is only one condition which is being tested, and the answer is specific, so if the answer is 1 or 2 or 3. They can't be used in cases where the answer is a range or is not specific. So for example, if the answer is less than some other number, you wouldn't be able to use a switch statement for that case. The layout and functionality of switch statements is also slightly different to an else-if statement. First off, we specify the variable we are going to test, which we do at the top of the statement in normal brackets. Next, we list each of the specific conditions that we want to take an action for. So here we have specific pieces of code being run, depending on whether the value of num1 is 1, or 2, or 3. Finally, we have the default condition, which can be considered the equivalent of else in a normal if-else statement. This will be the code which is run if none of the other tests is valid. You might also notice that we also have the word break at the end of each of the individual blocks of code. This is how we tell Java that this is the end of that specific block of code, and it's also where most problems arise relating to switch statements. If you don't include the word break at the end of the block of text, like in this example, and num1 is 3, then Java will go to the switch statement and see that 3 is a valid option. So it'll process that block of text, and we'll get a message saying that the value is 3, but Java will keep going. It will also show the message some other number, because we didn't tell it to stop after the first message. In fact, if we took out the remaining breaks and changed the value of num1 to 1, we would get every message output. If we took out all of the breaks and changed the value to 2, we would see all of the messages from the value is 2 onwards. The code doesn't move up, it just moves downwards. So you might be wondering why Java would allow you to do something as strange as that, and it does have its uses. For example, imagine you were creating a game and you wanted to give the player a new item whenever they leveled up, but you wanted them to still have access to all of the items at the lower levels as well. Well, if you created a switch statement to do that and didn't use breaks, you'll be able to achieve that without writing the same code many times. Imagine you had 50 levels. That would mean writing the same code to give your player an item 50 times. Or, with switch statements, you could just write that code once and let the higher levels fall through their individual case block. Just as a side note in case you want to look into this in any more detail. The process of not using breaks, and therefore allowing Java code to run through multiple blocks of code in switch statements, is known as allowing switch statement cases to fall through.